All right, welcome to this presentation. Before I start with it, I have to explain something. So originally, there was a presentation planned, the Theia architecture given by Thomas Meder. He unfortunately very spontaneously couldn't make it today, and I was asked to take the session over. I said yes, but please bear with me. I literally had no time to prepare something. What I would like to do, and I explain you what to do, and then you actually have the chance to leave if you're not interested, and no hard feelings. So I very frequently give Theia trainings. They're usually 4 hours, but what I would like to do is show some extract from this training about the Theia architecture and show you some things that I find important if you want to get started with Theia. And I hope and I'm confident that this will be useful for you if you're new to Theia and you want to learn something about the technical details and about the source code. However, I didn't have the time literally to prepare this and to, for example, practice it, whether it fits in 30 minutes or so. So I will give my best to provide something useful to you. We are sorry that this happened, but we cannot control that, so bear with me. I would like this to be a very interactive session, so you can ask any kind of questions. Thanks to, there are some Theia committers here in the room too, who will support me in answering all of your questions. So use the session, ask questions. I will do my best to present something useful to you. And if you evaluate the session at the end, please keep in mind that it was completely spontaneous. But we wanted to use the time and provide the content that you expect. Maybe not exactly the same content, but hopefully something useful. Right, so now who's not happy with that and wanted to see Thomas Meder but not me, I'm not angry if you leave, that's completely fine. Okay, let's get started with that. So topic is the Theia architecture. My plan is I would like to provide a high-level overview, and then I would like to dive into detail about one specific aspect, and that's how to create a Theia extension, which is this module concept provided by Theia, and I would like to focus on how this Theia extension is then wired with the Theia workbench. So essentially, from a feature point of view, how can you add your own feature into the Theia workbench, and how is everything connected then? Because if you start with Theia, that's typically the first thing you have to understand if you want to start extending Theia. Before we do that, I would like to show you, okay, what's the overall architecture and how does a Theia workspace look like? So how can you create your own Theia application? What are the most important artifacts? Where can you tweak things and so on? So you get kind of a sneak preview on your first development day in Theia. I would like to switch a little bit between slides and also live demonstration. I'm connected to my mobile internet because we deal with web development, so it has to download a lot of stuff. Potentially some builds will take very long. Keep that in mind if you watch me doing things. All right, let's start with the top-level architecture. You might have seen this before. Every Theia-based application consists of a front-end part and a back-end part. Front-end is running on in a browser engine. Back-end part is running on Node.js. Both parts are written in Typescript. However, especially on the back-end part, you can also integrate other languages, for example, a language server written in Java or a C compiler or stuff like that. But this is the core and how it's written, and this is what we talk about today. So I will not talk about how to integrate other things. And now the nice thing about this architecture is because of the split, we actually have two deployment scenarios for a Theia-based application. One is actually this one. If we deploy both separately and actually run the front end in the browser and deploy the back end somewhere in the cloud, we have a remote application that you can access from anywhere over the internet or an internal network. But we can also bundle both together into a desktop application using Electron, which is a framework made for this purpose. And then we really have a deployable desktop application. Technically, we still have the split between backend and front end, because what Electron actually is a local browser. So, and also the rendering is exactly the same technology, but the user would not notice, but the split is still there. So if you, and the nice message here is if you build a Theia-based application, you don't really, from an architecture point of view, you don't have to decide whether it will be a desktop application or a browser-based application or remote application. You write it the same way, and then you can even deploy both in parallel The only disclaimer here is if you want to support both, you need to test both, because there are some slight differences, for example, when it comes to native menus, or for example, when it comes to latency between the front end and the back end. It's obviously different when it's on the same machine, so you at least need to test it, and there are some, from time to time, some things that you need to take care of, but the overall 99% is actually the same for desktop application and a browser-based application. The reason why this is so great is that if we think about the migration path from an existing desktop-based tool to the web, what many companies do as a first step is re-implementing their front end in using web technologies, migrating some of their back-end business logic into the back-end here, and then as a first thing, deploy a desktop application. For users, they get what they are used to. It looks much better, typically, but it's still a desktop application. And the other aspect is you don't have to solve this hosting problem from day one, because hosting such a tool just adds completely new tasks to your tool department, which is solvable, but it's just some work. And this way you're not forced to take both tasks, like re-implementing the tool and the hosting at the same time. So this desktop application based on web technology is a very good intermediate step, and then you in parallel can prepare the cloud-based version. Disclaimer about this presentation, because this is a very long presentation, I will skip slides to come to the things that I would like to talk about today, so don't get confused about that. For example, this one. All right, let's dive a little bit into detail. What we see here is the conceptual view of the modular architecture of Theia. And I explicitly want to talk about Theia extensions, which is the core module concept in Theia. Every Theia-based application is completely built up of so-called Theia extension, which is technically they're a node package. And you can now combine an arbitrary number of these extensions and based on that build your own application. And what you typically do is you reuse a lot of the existing extensions that are provided by the project, like for example Theia Core, and then you might want to add the file explorer, an outline view, like all the features that you want to reuse. And then you add some of your own extensions that you then code yourself, which contain the features that you want to add to your tool that are custom or specific for your context. Now, if you have such a modular architecture, the crucial question is always how do these modules communicate with each other? And the question is crucial because these modules should be decoupled as much as possible, and they actually don't know each other when you create them. For example, the Theia extensions, they cannot know about your extension, but somehow these things have to communicate with each other to wire everything together. And to achieve that, in Theia, we use dependency injection context. In a nutshell, from a very high-level point of view, if you're not familiar with dependency injection, there is this dependency injection context. And you can consider this to be a global bulletin board, like a board and everybody, like all the extensions, they can put something on the board, and other extension can get it from there. And this way, you simply decouple the communication between the extensions. They don't have to know each other and directly communicate, but they all communicate over the central context. The only thing that they need to know is what do they communicate about, and that's, in a nutshell, typically an interface. So, for example, existing extension on the left side wants to publish a service that can be used by other extensions. So what it does, it pushes an object of type service into the dependency injection context, and all the other extensions, they only need to know the interface of this service, and then they can tell the context, hey, I want to have it, and this is how the wiring actually works. Thank you. All right. I had this in my first presentation, but I quickly want to repeat that, and then I will actually show that to you too. Now, if you want to build a Theia-based product, how does that actually look like in your workspace? So what are the building blocks here? So I mentioned before, a Theia-based application consists of an arbitrary number of Theia extensions. So these would be Theia extensions that are already existing and you just want to make part of your product. And as mentioned before, exactly 3, not more than less. You can also as a side note, also add VS Code extension. That's also supported by Theia. I will not focus on that today, but you can, all these features that are provided as VS Code extensions in the marketplace, you can also add to your Theia-based product. And now to define what is part of your product, you have what we call a product configuration. So that's the first and most important file in your own development workspace. That's really a file that now defines a list of all the things that are part of your Theia application. And now the simplest project that you could kick off is you just define, okay, I want this 10 Theia extension be part of my product and these VS Code extension, and then you can already build something that the user can start, and you could even deploy that. And there are projects that only do that just bundle existing stuff together and deploy that. Now, of course, it gets more interesting when you add your own extensions. And then in your workspace, you would have the source code, for example, for some Theia extensions and potentially some VS Code extensions again. And they would also go in here. And then you build again and you deploy. So that's in a nutshell how that goes. So how does that really look in terms of a typical folder structure in your workspace? So let's ignore the text above. So what I'm about to show you is now the structure of a typical development workspace for a Theia-based product. So on the root, as in all node-based projects, we have a package.json. The artifact on the root level is really more a development artifact. For example, it defines some dev dependencies and some scripts, and for example, the sub workspaces for the global build. So it's not really relevant for Theia. So let's ignore that for now. Now, we typically have one subfolder per every extension that we create ourselves. So this would be the folder that contains the source code of an extension that I personally, or that you create and code. This has a package.json in it too to define the metadata of this extension. And then we could have an arbitrary number of extensions. If you have many of them, you might put them in a subdirectory, but that's essentially it. And then we have typically two special folders, one called browser app and one called Electron app. And these are now the product configurations that I had on the previous slide. So this is actually defining what is in my product. And if I build this artifact, I really get my product out. Browser app for the browser-based version, the remote version, Electron app for an Electron application. Now let's look into these and only highlight the most important thing. The root artifact, as mentioned, is really a development artifact. What you typically need to modify or keep in mind is it lists all the workspaces and that are actually all subdirectories that are to be included in the global build. It gets more interesting when we look at the package.json of your extension. There are some other things in, but the two most important things is, first, it has a list of dependencies, and now these are the modules that your extension depends on. For example, if you use some interfaces from Theia core, you need a dependency on Theia core, and there might be other npm modules in there, third-party libraries or Theia extensions. Now, there's one special entry that is completely specific for Theia extensions, and we see that here, and I will come back to that a little bit later. This is what we call a module. You can consider, so this points to a code file. And this is the one and only entry point of your extension. And this will be the file that basically does the wiring. So here in this file, there is some code that connects your extension with the surrounding framework. And the framework somewhere, when it starts up and connects all these extensions, it somehow needs to have a pointer to this place in the code. And that's why it's here in the package.json. So if you're familiar with Eclipse Desktop, that's kind of the activator, pretty much like that. All right, and then let's look at the browser app package.json. So this is the product configuration. It also has a list of dependencies. In this case, the dependencies have a slightly different meaning. these are all the modules that are part of your product. So if you want to add something to your product, you would add it to this list. And then if you run the build, it will actually be added to your Theia-based product. And we see, for example, here, our extension is part of it and Theia core. So we have kind of a minimum product with only Theia core and our own extension. And down there, the target is defined. The Electron package.json would look very similar, but with another target instead of browser. All right, so let's look at that in the code to give you some better feeling on how that looks like. Maybe I should increase the font a bit. Is that readable? Good. So what I have here, and I will show you in a second how to create that, or actually, no, I will show you in a second. So what we have here is really a workspace of a Theia-based product. It has exactly one extension in there, which is this one, the Hello World. I generated that, and I will show you in a second how to do that. And I will now just show you the things that I just had in the slide in code. So the root package.json, as mentioned, it essentially contains development relevant stuff. You typically don't have to worry about that in the beginning, but what we see here, it defines the 3 workspaces, meaning sub-workspaces in my project, the Hello World extension, the browser app directory, and the Electron directory. All right, let's look at the browser app as a next thing and open the package.json here. Now, this is my product definition. And now we can see 2 things. One is the list of dependencies. And as we can see, my example product includes a couple of existing Theia modules, like Theia core, editor, file system, whatnot. And it contains my Hello World extension. Now I could actually build that. And last but not least, let's look at the Hello World extension and the package.json. Now this contains the dependencies, and this is because this is a simple extension. It just depends on Theia core, so there's very few dependencies. And then down here, it has this pointer that points to a code file that actually does the wiring. I will talk about this in detail in a second. What I would like to show you first is how do you build this now? So the brute force way is you could now execute the build on the root level, which would build everything, literally everything. And I could do this, but this will take forever with my current network connection, so I don't want to do that. And what you typically do during development is that you rather do a yarn watch. And by the way, in case you have never heard about yarn, should have mentioned that, that's an alternative to npm. If you don't know that, just replace yarn with npm in your head. So it's pretty much the same thing. It has historic reasons why Theia uses yarn. So when I now want to start my development, what I would typically do is I would start a watch, and the reason for that is a watch is an incremental recompile on every change. So if I now would change something in my extension, it would recompile the extension, and I do the same for the browser app. And if I set this up this way, I can change my code, and then in the browser just reload, and it would reflect the changes. So let's do that. I do that for my Hello World app, and I do that with yarn watch, like this. And then I just create a second terminal and do it for the browser app, like this. And then I start my application. So my application, if I want to start my application, I have to choose the Electron app or the browser app. I will start the browser app. So I change to this directory, and now I enter yarn start, which will start my product configuration. So let's do that. I hope it works. And now let's go to the browser. Now we can see this is the application that launches here. This is what I just built, or what I just started. And now to prove you that this is the same thing, I can now execute the code that I have contains one command that says hello. And I can execute that, say hello, and we see down here it says hello. And now let's test the the incremental recompilation. So I will quickly go to the place where it actually says hello. So what's your name? Guido. Guido, okay. It's magic. Right. And then I go here and I press F5. I have to read out the application because the code is in the browser. And now let's say, let's say hello again. Hello, Guido. So that's the basic development flow. All right, let me look at the time. All right. Now the next thing that I would like to, next and probably already last thing that I would like to show you is how does now this extension wire into the workbench, and more specifically, how is the command that I just showed you, how is that added to the existing application, because it's a modular thing that we just add to it. So Theia doesn't know about it, and somehow it has to be aware of that. And the reason why I focus on this is really one of the core concepts to understand when you start with Theia. The good news, in general, Theia is really standard web technology, so many things will be familiar if you've worked with web project before. However, this contribution mechanism is a little bit special. All right, so let me go a little bit further. All right. So two things that I would like to explain. Usually I have longer to explain this, but here what we actually have here on the slide is this dependency injection scheme again, which is very central to the architecture. And the idea again is, on the left side we have a provider. That's a module that provides something, in our case a command. On the right side we have a consumer. That's an element that wants to retrieve something. For example, this could be the class in Theia that shows the list of commands, so that needs to retrieve it. And now these two things want to communicate with each other, but they don't know about each other because we add the extension, so Theia cannot know about us. And the way how this is solved is we have this dependency injection context as a central place, and now the provider can put something there, and the consumer can consume something there. And the only thing that both parties need to know is a key, meaning they have to agree, okay, like if somebody would just put something there, the other party need to know, okay, how to retrieve it. And this key is conceptually an interface. So that's what we have in the middle. So provider will put something there and specify an interface, and the consumer will actually pick it up. Now, let me go a little bit further here. No. Yeah. So conceptually, and I will show you that in the code in a second. Conceptually, what we do is in the Theia core extension, we have the command registry. And that's the service that can actually fill this dialog here. And we have our extension on the left side. Our extension conceptually contains our command. That's the hello world command that we want to add. The hello world command, on the other hand, needs a message service. That's, again, a service that is provided by Theia to say hello. That's the service that is capable of opening this window here. So we have a communication in both directions. And now to wire, so this is the end state, like if the application is running, this is really how things are wired together. Now to connect everything, what we do is we use a so-called contribution. That's really a construct that is only used for wiring. And we add that to our extension, and it basically contains our command, and it wires our command with a command registry and the message service. And I'll show you the code in a second. Now, at startup, Theia core will actually look at our command contribution and execute it, and there is the code that actually puts everything together. After that, the command contribution doesn't matter anymore. It's really only like connects everything together artifact. Now the interesting question is, how does Theia find our command contribution? Because it's just in our code, and somehow we have to tell Theia that it's there. And this is exactly where dependency injection comes into place. Every extension has this class that is called a module. And this is the class that I showed before in the package.json that is referenced there. It's kind of the central entry point for every extension. And conceptually, we list our command contribution in this module. So we basically tell Theia we have such a contribution somewhere, so that Theia knows where to pick it up and where to execute that. All right, let's look at the code. All right, so I would like to start with the module. So that's the class that is referenced in the package.json. So if we start here, this is the package.json of my extension, and it has a pointer to this hello world front-end module. Again, this is the one and only entry point to my extension. This is the only thing that Theia knows about. And let's look at that. Let's ignore the second one. This one is the important one. I will ignore the details, but what we do here is conceptually we say, hello, we have a command contribution, and this is the file. This is our instance of a command contribution. And because of this registration, and this is basically put into this global context, Theia knows, okay, there is a command contribution, and I can call it, which wires things together. Again, ignore the details, just understand, okay, this is telling the world, here's a command contribution, and this is our concrete instance. And now let's go over there. Now this is command contribution. Again, this artifact is only for wiring. At runtime, it doesn't play a role anymore. And what it actually does here, it implements a function that is called register commands. And this function will be called by the Theia framework on startup. And the reason why, again, why Theia core can do that is because we added to this global bulletin board. And now what happens here is we call, on the command registry that we get here as a parameter, we call register command, our command definition, which is an ID and the label that we specify up here. And then here we basically add a function, one second, that then calls the message service. So in our command, we call back to the framework and say hello. And I come back to your question in a second. To complete that, now the reason why we can access the message service here is because we do not only put this command contribution in the context, but we also get other things from the context injected here. And that's a typical scheme in dependency injection. So we get the message service, and the message service has been put there by Theia core again. And now at runtime, Theia core will pick this up. It will call this function, and then we can actually put our command into the command registry, and then everything is wired. So you had a question.
Yeah, I'm not used to Typescript, but I see here a constructor that takes that gets parameter injected, which is called message service.
You're missing the field assignment.
Sorry?
Are you missing the field assignment?
Yeah, I expect it to be like a silent assignment to a...
Yeah, that's exactly it. So
okay,
it's,
so
yeah.
we don't need, okay,
Yeah,
just
yeah. All right, I would like to actually, so because we are kind of coming to an end of this session, is that correct? So I would like to leave this here and open it up for other questions, because this actually, the good news about this is I know this was pretty fast, and as explained in the beginning, I literally had no time to prepare this, so this was very spontaneous. But the good thing about this example here is, if you see it the first time, it's probably a little bit complex to understand. The good news is most contribution points in Theia work very similarly. So for example, if you now want to add a menu, scroll down here, it's a menu contribution. It has a function register menus, which gets a registry in again, and then you just add it at the right place in the menu, and then for the respective part, we say, hello, we also have a menu contribution, and this is our menu contribution. There are little bit different ways also, but this is really the core concept. So if you understood this, this indirection and essentially this pattern, you already understand a lot of how to interact with Theia from the viewpoint of Theia extension. And again, the way so this might sound a little bit overcomplicated in the beginning, but this is actually enabling modularity. If you don't have a concept like this, you would just call, like you would have the spaghetti code, and you would not be able to combine existing code with your own thing. Now, if you really implement a feature at the end, for example, there's a similar contribution point for what's called a widget in Theia, where you can add your own UI to Theia, meaning you could open a view, and then in this view it displays some custom UI, a chart, a diagram, whatever. You also have a similar concept, but if you're done with the wiring, essentially, like if you connected your own widget with Theia, what happens after that is really standard web development again. So you can, for example, just create a React component, code it like you would do it anywhere else, and this is the place where you actually connect it to Theia. So the special thing that you have to learn in a platform like Theia is typically how to connect your own custom code into the platform, not so much like how to implement features. Like, for example, what you do then in this command here, I'm just saying hello. If you want to trigger, I don't know, a business logic or a compiler or whatever, that's up to you. You have to understand, and you understand how to do that. Like, you have to learn how to connect it to Theia. Yeah.
I just want to go back on the question artifact. So to understand a bit better this binding stuff, because essentially the modules where you bind a symbol, which is a service identifier, something just to reference a concept, just like command contribution, and then two actually takes the constructor as argument, because it's the inversified framework that does all this magic for us, that will instantiate your instances. So if we go back to hello world, the inject decorator wheel does actually nothing when your class is passed, but it registers, like it's like a type put on your class that Jonas can read and say, oh, when I construct this instance, I need to give it the binding for this. So this is when the assignment is done. It's when services diversified bindings are resolved. These statements are used as tags to know what to inject when constructing the instance. So diversified will need to give something in this instance parameter, and this annotation is what tells it in advance what we expect to get.
Thank you. So if I try to make a parallel, I can think about diversified like what the string is for Java, so it implements the inversion of control in the JavaScript.
It's inversion of control, so it's classic dependency injection. So if you're used to Guava or, for example, E4 or something, it's exactly the same pattern. Yeah.
Okay. It is not a feature. This is what interesting. It's not a feature of the Typescript. It's really the framework.
Yes.
Inversion. Okay. Thank
you. When I wrote this code extension, I did the setup, and it was a little bit similar like this. We're using a command that worked. It's always the same. But what me really frustrated was coming from Eclipse RCP or Eclipse plugin development. I was used to have something like the J phases where you got a table, you can put millions of things in, and it was very easy. When I come to VS Code, I got the problem, I have only trees.
You have only trees?
Only trees.
Yeah.
Everything was a tree.
Okay, so but
my question would be here, I have these message service, okay. Is there something similar, easy to use, like the J phases part in Eclipse, EDE? So when you want to have a table, you don't have to put always HTML5 around and do your own view, but just have say, okay, here's a tree, here's a table, I put it together, and I get my tree provider or my table provider, and I'm done.
Yeah.
I do everything on my own like this.
So to answer, there's some support for trees if you want to like extend existing view, but if you really want to implement a custom tree somewhere or a custom table, then Theia doesn't include its own UI toolkit essentially. So the answer to that, and there's actually a good reason for that, because if we now are on HTML and JavaScript, there's so much out there, like for example React, that you can just use. And in Eclipse, the situation was a little bit special because Eclipse essentially had its own widget kit, right? So there was no other ecosystem that supported that. From an UI point of view, Theia, we are a standard technology, so you can use the full ecosystem that is available there. That makes it maybe initially a little bit harder for you because you have to decide, but on the other hand, the big advantage is you can decide, right? You're not bound to a JSpace table. You can use any table framework you like, which is coming from this huge ecosystem that is the same as used in business applications. Yeah.
These are stupid questions.
There are no stupid questions.
What if I want to write an extension because I have a problem on performance in WebAssembly?
Yeah. So we are starting to experiment with putting some.
I couldn't hear the question.
Yeah, sorry, I forget to. So is there support to write extensions in WebAssembly? So by default, no, there's no standard mechanism where you can just do this. We are starting to experiment with putting some specific parts of the application back on the client. We're currently not doing this with WebAssembly, but actually with no Notepad, you could potentially also integrate WebAssembly, but you have to care about that in a special way. There's no generic support. It's technically doable, and if you have a good use case for that, so one could, for example, be if you have very complex layouts and you want to calculate them on the client. So you
The reason is because it's opening the door, because usually you use a slow interface because you generate code, but you open the door for the tooling that get the data, visualize data from maybe some hardware, and you have to be.
Yes. Yeah. So there is no technical reason preventing that, but Theia has no explicit support for that or anything generic. You want to comment on that?
Just want to add something, just a bit of trivia about Theia. So for syntax coloring in the editor, we actually run a bit of WebAssembly in order to pass special regexes, and in order to make coloration fast. So we mimic what this code does, and it's basically, exactly the use case. Something had to be fast, so it's WebAssembly actually running.
I would like to close because I think we're end of time. I promised you to show you how to get to exactly the state that I had in the workspace if you want to play around. There is a yeoman generator. That's a template generator with which you can create template projects to get started with Theia. You find that easily on the website or just Google for yeoman Theia. And if you run that, it looks like this. And then you can select which kind of extension you want to start with. For example, the Hello World was the one that I showed you. Widget would be a custom UI, label provider, TOA editor, backend communication, an empty one, or a diagram editor. These are the templates that we currently support. And what you will get is exactly the same workspace that I had. So you are immediately able to launch a Theia-based application. You can start to code in your extension. So that can directly get you started, and you can try out Theia. Now, before I close, I want to mention for those people who joined again, I'm not the speaker. So a completely different session was planned. I was asked very spontaneously to take over and tell something about Theia, so that's why the slides that were not completely matching, and that's why I skipped slides, that's why the timing was not perfect. I hope I could provide you some useful content. Of course, we're here for questions. Also, thank you, Mark and Paul, for joining and helping with the questions. So here are two Theia committers. Use the time, ask questions, and if you evaluate the session, please don't write in the speaker was not prepared, because I had no time to prepare. So thank you very much.